very warm welcome and thank you for joining Spotlight on Canadian Sustainability and Climate Action webinar. We will hear a series of experts presenting today. A panel discussion will follow after that, so stay with us till the end. Please welcome Mr. Charles Reeves, Acting High Commissioner of Canada in Malaysia, for his remarks. But before that, here's a video for your viewing pleasure.
Thank you very much, Yamuna. Dr. Gary Tissera, Chief Climate Action Officer of Malaysian Green Technology and Climate Change Center, senior officials from ministries and agencies, and honored participants. Good morning and welcome. Bonjour à tous et toutes et bienvenue à notre webinaire canadien au sujet de durabilité et l'action pour le climat. Saya dengan suka citanya mengalu alukan hadiran sekalian ke webinar Anjuran Canada. As Canada's Acting High Commissioner to Malaysia, I am pleased to welcome you to today's session on sustainability and climate action, organized by the High Commission of Canada, Malaysia, and GRC Capital, in collaboration with the International Green Tech and Eco Products Exhibition and Conferences Malaysia 2020. Canada and Malaysia have a long-standing, robust relationship encompassing bilateral cooperation in a number of areas, such as education, defense and security, and trade. In fact, diplomatic relations were established between both our countries over 60 years ago, shortly after Malaysia's independence in 1957. I'm happy to say that since that time, Canada-Malaysia trade and investment relations have grown exponentially over the last 2 decades. In 2019, Malaysia was Canada's 4th largest bilateral merchandise trading partner among ASEAN countries, with two-way trade in goods amounting to ringgit 11.39 billion. Included in this impressive trade relationship are Canadian clean tech merchandise exports to Malaysia. In 2019, these exports were recorded at ringgit 58 million and mainly comprised valves and similar appliances, controlling instruments, and photosensitive semiconductor devices. According to the latest Global Clean Tech Innovation Index, Canada's clean technology sector ranks 4th in the world and 1st in the G20. Canada surpassed both the United States and the United Kingdom, up from our 7th place global ranking in 2014. In addition, 12 Canadian companies were featured in the prestigious Global Clean Tech 100 list for 2020. Canada wholly supports global efforts to transition to low carbon, environmentally sustainable, and climate resilient economies and societies. And we do so through initiatives that will reduce global greenhouse gas emissions, improve climate resilience, and protect and sustainably manage natural resources and ecosystems by addressing pollution and managing waste. Canada's approach to environmental and climate action is consistent with Canada's commitments under the Paris Agreement, including the achievement of the Pan-Canadian Framework on Clean Growth and Climate Change. Acknowledging the importance of sustainability and climate action, Canada is ready to collaborate with economies such as Malaysia, who take climate action just as seriously. Malaysia's latest commitment, reflected in its nationally determined contribution to the Paris Agreement, is a reduction of its emissions intensity by 45% by 2030, with 10% of this goal contingent upon international assistance. As you will hear later in this webinar, Canada's strength in environmental sustainability covers diverse subsectors such as carbon capture technologies, greenhouse gas emissions tracking, and waste recovery. Companies like CarbonCure, GHGSat, and Terragon are global leaders in the respective subsectors, and I'm very excited that they are able to share their thoughts with all of you today. Ladies and gentlemen, mesdames et messieurs, I'd like to recognize and thank the speakers and exhibitors from Canada who joined our webinar today. Your participation signifies your commitment to doing business with Malaysian companies and organizations and sets the foundation for further potential collaboration between Canada and Malaysia in the clean tech sector. I'm further very pleased to see all the Malaysian participants who have joined us today to learn about our clean tech capacity. I would encourage you all to reach out to the individual speakers and exhibitors through our Canada Pavilion at iGEM's virtual booth to explore partnership opportunities. Merci à tous et toutes pour votre participation au webinaire ce matin et j'espère que la session a été informative. Saya berharap webinar Anjuran Canada hari ini produktif bagi semua. Thank you. Merci. Terima kasih.
Thank you, Mr. Charles, for highlighting those key points. Next, I'd like to invite Dr. Gary Tazira, Chief Climate Action Officer from Malaysian Green Technology and Climate Change Center, to deliver the opening remarks. Dr. Gary brings us more than a decade of experience in climate change and sustainability policy development, communication, and negotiation at international and national levels. He advocates for science-based policymaking, multi-stakeholder consensus building, and conflict resolution. Please welcome Dr. Gary Tazira.
Your Excellency, Mr. Charles Reeves, Acting High Commissioner of Canada in Malaysia, distinguished presenters and panel members, online participants, ladies and gentlemen, a very good morning to you. It's a distinct pleasure to have been invited to deliver some brief opening remarks at this Spotlight on Canadian Sustainability and Climate Action. On behalf of the newly repurposed Malaysian Green Technology and Climate Change Center, or MGTC, I would like to thank the High Commission of Canada in Malaysia and GRC Capital for their kind invitation at this virtual iGEM 2020 event. Distinguished participants, the global consensus has unequivocally concluded that our climate has changed in unforeseen ways due to human activities, with impacts to developed and developing countries alike. Moreover, the changes we are currently experiencing are likely to worsen indefinitely if we do not take immediate and decisive action to reduce greenhouse gas emissions and shift to a sustainable low emissions economy. When the COVID-19 pandemic began in China, the world was ignorant of, and to a large extent unprepared for, the global crisis that would follow. But now we know a great deal about climate change, and we must seize the opportunity to take the steps necessary to stop and reverse it. If the global experience of trying to address climate change has shown us anything, it is that there is currently no single technology, no single sector, and no single activity that alone has the potential to reduce greenhouse gas emissions at the needed scale to prevent dangerous anthropogenic interference with the climate system. Not unlike working towards achieving the 17 Sustainable Development Goals, climate action must be driven across the full range of economic sectors, at all levels of government, and must encompass all the systems that keep our human civilization functional. But our first, and in many cases most difficult obstacle, is our resistance to change. And human civilization is littered with the ruins of great empires that were not able to change to keep pace with environmental changes. But there is a growing list of actions and initiatives in which forward-looking planners, a vibrant civil society, and bold political leadership are pushing the boundaries, challenging the norms, and above all, dispelling the myth that our civilization is doomed to follow in the footsteps of numerous human civilizations past. How has this been accomplished? Well, it has to be a kind of perfect storm. Firstly, learning from the mistakes of the past. We need to understand why initiatives have failed and how we can make them succeed. Second, continued education at all levels and for all ages. A culture of lifelong learning, trying to understand how changing our lives can change the future. Third, a willingness to challenge cultural and social norms about what constitutes quality of life. Fourth, investing in sustainability at all levels, from individuals and households to the federal government and across all sectors: food systems, mobility systems, communication systems. And fifth, and most importantly, putting in place an ecosystem of affordable, accessible, and effective alternatives to the unsustainable systems for which, in many cases, we still have no technologically or economically viable alternatives. Distinguished participants, at this session, we will shine the spotlight on 3 Canadian companies. 2 that have developed and commercialized technologies that hold the promise to significantly decarbonize 2 of the most problematic and recalcitrant sectors, together with a 3rd that provides a unique imaging service to help countries measure and monitor greenhouse gas distributions swiftly and remotely. I will end my opening remarks here. You have not registered to listen to me. I am confident that the Government of Canada has brought to Virtual iGEM 2020 the very best in Canadian technology and know-how. I thank you.
Hello again. Just a brief note before we begin. We shall have all the presentations back to back and follow that up with a question and answer session immediately after. Please feel free to submit your questions as the recordings are being played and you're listening to the presenters. To the presentations then. Our first presentation is by Mr. Kaya Solovsky. He's the Vice President of Business Development at Carbon Cure. Carbon Cure have taken a unique approach to removing carbon dioxide from the atmosphere. Essentially, they lock it in the concrete that they produce. Mr. Solovsky, you have the floor.
Hello, everyone. My name is Kaya Solovsky. I'm the Vice President of Business Development for Carbon Cure Technologies. It's my pleasure to be with you today to deliver a presentation entitled Reducing the Carbon Footprint of Concrete. The agenda will start with some background on Carbon Cure, a brief explanation of why we've chosen concrete as our target market, our technology offering and value propositions, our market impact to date, and then a brief summary and how it may relate to Malaysia. So who is Carbon Cure? Carbon Cure's vision is to make the introduction of carbon dioxide into concrete the global standard for all production. Our mission is to reduce 500 megatons of carbon dioxide per year. That is equal to taking 100 million cars off of the roads. We were founded in 2012 by our CEO, Robert Niven. We are currently in use, in production, in over 250 concrete plants in North America, Latin America, and Southeast Asia. We were voted in 2020 as North America's Clean Tech Company of the Year. We are investor funded and are very proud to have all of these companies as part of our network of investors. Most recently, Amazon, Microsoft, Taronga Group, and 2150 joined a broader group of investors that was anchored by Breakthrough Energy Ventures, which is chaired by Bill Gates of Microsoft. Why do we use concrete? I think most people recognize that concrete is used very frequently. If we look at all of the other industrial materials that are used by human beings, concrete by far outweighs all of the others. So why does humanity choose concrete as a building material? It's relatively low cost. It's extraordinarily resilient. It can be recycled at the end of its life, whereas wood, as an example, cannot. It's tremendously versatile, dependent on geology, geography, altitude, weather, soil conditions, or shape. You can't get more flexible than concrete. And the ingredients are very local. Aggregates are everywhere. Water is relatively plentiful. And cement's raw ingredient, limestone, is frequently occurring. So our technology offering and value propositions are very nicely explained in the following video.
CarbonCure is clean technology that allows ready-mix concrete producers to reduce costs, deliver greener concrete, and win more business. CarbonCure works by injecting recycled carbon dioxide, CO2, into fresh concrete during mixing. Once injected, the CO2 undergoes a chemical reaction where it transforms into a mineral, improving the compressive strength of the concrete, which then enables the reduction of cement content in mix designs while maintaining strength requirements. The CarbonCure technology is made up of two boxes: the control box, which is the brains of the operation, and the valve box. The valve box connects to a CO2 tank and delivers a metered quantity of CO2 into the concrete mix. The CO2 is stored on-site in a pressurized tank provided by industrial gas companies. The control box monitors the performance of the valve box system in real time and feeds back all usage data to the CarbonCure command center. The control box software integrates seamlessly with all existing batching software, so adding CO2 into a mix is just like adding an admixture, meaning no impact on batching or loading cycle time. Transfer hoses deliver liquid CO2 from the supply tank to the CarbonCure valve box, which is at the plant loading area. The valve box then meters and delivers a known amount of CO2 into the concrete mix based on the cement content of the mix. The CO2 automatically injects into the mix once roughly half the cement and water contents have been discharged. While liquid CO2 is stored in the tank on site, the CO2 that comes into contact with the concrete is actually in a solid and gaseous state, similar to dry ice or snow. It changes state once it leaves the CarbonCure valve box due to a significant drop in pressure. Upon contact with the mix, the CO2 undergoes a chemical reaction and converts into a mineral, calcium carbonate, which makes the concrete stronger. Plus, what was once CO2 is now eliminated, never to be re-released into the atmosphere, even if the concrete structure is demolished. Concrete made with CarbonCure has no differentiating factor from concrete without CO2 in it. Fresh and hardened properties are not affected. Any mix design can be adjusted to include an optimized dose of CO2 and a reduction of cement content without compromising the concrete strength. This means CarbonCure mixes can be used for all commercial and residential applications. Every cubic meter of concrete produced with the CarbonCure technology saves an average of 17 kilograms of CO2 emissions from entering the atmosphere, An average high-rise building built with CarbonCure would save approximately 680,000 kilograms of CO2 emissions, which is equivalent to the carbon absorbed by 360 hectares of forest in a year. Reduced cement content means reduced costs and a reduced carbon footprint, and more business from the green building markets. With CarbonCure, concrete producers can create a legacy of sustainability in their communities while attracting and retaining employees who want to work for an employer that does something positive for the environment. Technology costs are offset by cement savings, one-day installation of the technology without disrupting operations. The technology can be retrofitted onto any wet or dry batch ready-mix plant. Seamless integration with your existing batching software means it's as easy to install as it is to use, all provided with the ongoing guidance and support of a dedicated CarbonCure technical services team member. Join the growing network of concrete producers who are using CarbonCure in hundreds of ready-mix plants around the world. It's simply better concrete.
And now I'd like to tell you a bit about our market impact to date. Our technology adoption is still in the early days. The countries in orange are countries that have either adopted the technology through our producer partners, or where we have signed commercial agreements with distributors or have secured regulatory approval. So as you can see, we are still looking for partners in much of the world, including Malaysia. The environmental impact and the production impact are growing every day. We have poured almost 6 million cubic meters of CarbonCure concrete to date. We've been implicated in many different types of projects, residential, commercial, even departments of transportation are using us now on roads and bridges in the United States. And it's important to note that we have been successfully used across all exposure classes and applications of concrete. The environmental benefit is now almost at 90,000 metric tons of CO2 avoided, and continues to grow every day. So in summary, the addition of waste or recycled carbon dioxide into concrete has a neutral impact on all of the key fresh and finished properties. So if durability is a concern, we are the same as the concrete without carbon dioxide, with the added benefit of reducing the concrete carbon footprint by somewhere between 17 to 20 kilograms per cubic meter. So with that, I thank you for your time, and I look forward to speaking with some or all of you to discuss how CarbonCure can bring this technology to Malaysia and your ever-growing base of concrete structures. Thank you so much. My coordinates are here. If you wish to connect by email, by phone, if you wish to discuss what the financial and/or environmental impact of our technology is, I look forward to hearing from you. Thank you so much.
Thank you, Mr. Salowski, for a very informative presentation. Our next speaker is Jean-François Gauthier, Vice President of Sales and Marketing at GHGSat. GHGSat is a company which provides a technology to remotely sense methane emissions in the Earth's atmosphere. Mr. Gauthier, you have the floor.
Hi, my name is Jean-François Gauthier, and I'm Vice President of Sales and Marketing with GHGSat. Thank you for the opportunity to introduce you to our technology today. Before we get started, allow me to go through some of the objectives for this presentation. You'll be introduced to the first and only satellite system specifically designed to monitor methane emissions from industrial facilities around the world. I'll introduce you to the technology we use and some of its key advantages. I'll also share some examples of measurements made with our satellites, and finally, I'll discuss the applicability of the technology to the Southeast Asia region. JHDSat pioneered the monitoring of methane emissions directly at individual industrial facilities with satellites in 2016 with the launch of our first satellite, JHDSat-D, also called Claire. A second satellite, named IRIS, was just launched on September 2nd, and a third one is scheduled for launch in December of 2020. Both of these satellites provide a 10 times improvement in performance over our first demonstration satellite. By the end of 2021, 3 more satellites will have joined these 3 satellites in orbit, with 5 more coming by the end of 2022. So at that time, the constellation will have grown to 10 satellites. Each satellite takes imagery in a 12 by 12 kilometer image at 25 meter resolution with a revisit rate of 15 days. Now, as more satellites are added, this revisit time gets shorter and shorter in a matter of days, and ultimately will be less than a day when we have 10 or more satellites in orbit. Let's take a quick overview of the technology we use. So the instrument on board our satellites is a spectrometer. It measures the absorption of sunlight by gases at very specific frequencies. In the case of our instrument, we operate in the short-wave infrared bands, also called SWIR. This is a very well-proven technology that's been used on the ground and in space for decades for the detection and measurement of gases. The simple figure at the top of your screen shows the configuration of our instrument, which is very much like a normal telescope. The light comes through a lens at L1, then travels through a collimating assembly at L2. It goes through the spectrometer, then through the L3 lens before reaching the camera detector at the back of the instrument. In this case, our instrument is specifically tuned to look for absorption at frequencies that are specific to methane. In the figure on the bottom left of your screen, you can see the absorption line of methane in blue across the frequencies of interest. The vertical dotted lines represent distinct features that are unique to methane compared to other gases. So when absorption is measured along those lines, it is a clear indicator that there is presence of methane. The spectrometer we use is a bit different from typical vertical grating spectrometers most would be accustomed to. It's a ring spectrometer, also called a Fabry-Perot spectrometer. In the picture on the bottom right, you can see that each faint gray ring represents a different frequency, increasing from the center of the instrument to the edge of it. Using satellites to monitor greenhouse gases isn't new, but before 2016, it was not possible to look at emissions from individual sites. The high resolution is what makes it possible. To better understand why high resolution is necessary, this table highlights the difference in performance between existing platforms like JHDSat and TRPOMI from the European Space Agency, and upcoming missions like MethaneSat and GeoCarb. The difference in resolution in the table is obvious, with JHDSat at 2 orders of magnitude better than any other system, with resolutions in the tens of meters compared to kilometers for other systems. Again, this high resolution is absolutely critical for reliable identification of the source of emissions. However, there are a few other key advantages. First, the high resolution allows for measurements to be made in partly cloudy conditions, providing the ability to essentially see in between clouds. TRPOMI data availability worldwide for methane data has been around 9% historically, in large part because of the presence of any clouds in a 7 km by 7 km pixel renders it useless. In contrast, JHDSat measurements have been successful 57% of the time over the last 4 years. More importantly, the detection threshold of JHDSat satellite is up to 100 times lower than publicly available data. This means that not only can emissions be attributed directly to the source, but emissions from sources that are 100 times smaller can be seen compared to public data alone. Next, I'd like to share with you some examples of measurements that we've made around the world. These 2 examples are examples of measurements that were made with a single pass of a satellite in less than 20 seconds. On the left, we have a coal mine, an underground coal mine in China, which from what you can see in the image, you can see the surface operations of this mine. So you can see some buildings, and the plume is emanating from a surface vent used to remove the methane from the underground mine in order to keep it safe. Now, there is no question, no argument as to where this plume is originating from. It is clearly associated with this vent. On the right, we have an example from the Permian Basin in Texas. This is a midstream oil and gas facility, and you can see in the image that the plume is once again very clearly associated with a single facility. In this case, several holding tanks can be seen in the image. But what's really striking here is that in this particular image, there are dozens of other oil and gas facilities around this particular plume, yet it was possible to determine exactly which one of these facilities was responsible for the emission, something that, again, is a key advantage of what our satellites can do. So next, let's turn our focus to Southeast Asia and how our technology is ideally suited to help understand methane emissions in the region. So methane is generated in several sectors in Southeast Asia, including offshore oil and gas, agriculture, hydroelectricity, waste management, and of course, LNG, as it takes an increasingly important role in the energy transition, especially in Southeast Asia. So looking at offshore oil and gas measurements, satellite measurements in the shortwave infrared over water are actually a big challenge for satellite measurements. So water absorbs light instead of reflecting it back to space. Therefore, measurements over water are usually not possible. However, there is a methodology, a mode of operation for the satellite called glint mode, which allows for measurement over water by looking at targets at a very acute angle instead of looking at it straight down from the satellite. This makes it possible to capture the glint, the reflection of the sunlight at a high angle off of the water. So measurement of offshore oil and gas rigs is something that's been of interest for a long time because these facilities are particularly difficult to reach, and also they tend to be very dangerous environment in terms of safety. So sending personnel to monitor these sites and be in the way of personnel responsible for the operation is typically a safety hazard. So if we look at the total number of these sites around the world, there's over 1,500 rigs around the world, but focusing on Southeast Asia, there's over 150 in Southeast Asia alone. And if we expand that to Asia as a whole, we're looking at well over 350 rigs. So there is definitely a need for monitoring these sites and better understanding these emissions. We are investing in developing capability to make these measurements over water, and we expect that this capability will be available in the middle part of next year. Next, let's take a look at emissions from agricultural facilities, more specifically in Southeast Asia. So agriculture is an important source of emissions, and GHGSat can very specifically address emissions from, for example, from livestock or even palm plantation. So there's over 5.9 million hectares of oil palm plantations in Malaysia alone. And these facilities often have lagoons where the byproducts of the production are stored, and they generate vast quantities of methane. However, the actual impact of these is not very well understood. Quantifying these emissions can truly help justify the economic viability of installing a biogas recovery system so that this gas can be used for other purposes, for example, generating electricity for the plant or for a nearby village. Then another aspect where the technology can truly play an important role is with livestock. So by better understanding the emissions from livestock, especially beef, but also pork and other large farming facilities or complex, by better understanding these practices and the emissions, it becomes possible to evaluate their impact and also the impact of improvements that are being put in place, for example, introducing alternate sources of feed. Another sector where the JSHISAT satellite technology is very useful is hydroelectricity. So hydroelectricity is often associated with a very clean form of energy, a very green form of energy that's fully renewable. And by and large, that is true. I mean, hydroelectricity is renewable and it's much cleaner than many other sources. However, in some specific conditions, it can also generate vast amounts of methane, especially in tropical regions where the climate is a little bit warmer and with newer facilities. And this is a result of organic matter being trapped in the water when reservoirs are flooded. And the methane is a result of the decomposition of organic matter in that water. When that water gets expelled over the dam, like in the picture you see at the bottom left of your screen, the methane gets degassed and released into the air, and this is a very strong source of emissions. So the example you see at the top left of your screen is a facility in Cameroon in Africa that we've been able to measure several times. And this is just on the other side of the dam, much like I just explained, where the water gets agitated and methane gets released. So satellite measurements are ideal for these types of applications because they make it possible to monitor these facilities frequently, but also in a single image. So in a 12 by 12 kilometer image, you can capture the dam itself, but also the entire reservoir that's behind it, which is something that's very unique and it's actually impossible to accomplish with other technologies. In this way, the seasonality of emissions can be better understood, and this can, for example, help with optimizing the operations of the dam. That real data from these existing facilities also starts informing future designs so that emissions can be minimized. And also, the financing of these sites is also often resting on environmental assessments. And these environmental assessments increasingly take into consideration the entire life cycle of the facility. So understanding emissions throughout the life cycle of a hydro plant is crucial. Waste management is another sector where satellite measurements can be very interesting. Landfills and dumping grounds can be very important sources of methane. Understanding these emissions is key, and to truly understand it, measurements have to be made not just once, but repeatedly. And again, being able to take measurements of emissions in a single image over a large landfill, which sometimes can be several square kilometers in size, is a true advantage because then you can avoid having personnel canvassing the whole facility, which can sometimes be dangerous, but most importantly, can take weeks. So this information is really critical for decision making. For example, this understanding of emissions and the patterns across the year can help justify and optimize the installation of a gas collection system over the landfills. In addition, the identification of the presence of hotspots over the landfill can also help prevent fires because the waste can be shifted around a little bit to facilitate the degassing and then prevent fires which could occur and rage for weeks and sometimes for months. The example you see on the right of your screen is a landfill in South America we've been able to measure, and this is a great example because you can see this is a very large facility, but the emissions that are being noticed are on the working face, so the area of the landfill where waste is currently being dumped and currently being moved around. So in contrast, the area on the right which is the older part of the landfill was already capped and has a gas collection system already installed. So you can see that the emissions there are not noticeable. So finally, LNG is becoming a very crucial part of the energy transition, and this is no more true than in any part of the world outside of than it is in Southeast Asia. So in other words, Southeast Asia is really increasingly reliant on LNG, and the decarbonization of LNG is actually crucial to its credibility and viability as a transition fuel, because if 3% of emissions of the methane is leaked, or if the gas is leaked between extraction and delivery to the customer, then environmentally LNG is worse than coal. So identifying and capturing these emissions and stopping leaks across the value chain becomes critical to the viability and credibility, as I said earlier. So on the left here, it gives you an example of some LNG facilities and how we can measure them. So these are 3 large terminals, LNG terminals in Australia, and the red square shows a 12 by 12 kilometer image from our satellite, highlighting the fact that not only can we measure a single one of these facilities at once, but we can do all 3 at once. So when you zoom in a little bit more on these sites, looking at what type of information you can get, you can see the 25 meter by 25 meter grid, and of course we can't identify exactly which valve or which flange is leaking. However, we can definitely help operators better direct personnel and optimize their operations on the ground, so they can go to a very specific part of the plant in order to fix the leak and prevent the loss of product. So again, these measurements can be repeated on a regular basis and truly help optimize the use of personnel on the ground. So in summary and conclusion, there's a few points I'd like you to remember once you walk away from this presentation. So first, it's important to remember that when it comes to satellite imagery to monitor methane emissions, high resolution is not just important, it's absolutely crucial. Data is always better than estimates and calculations, which usually overestimates emissions. And finally, with the right data, action can be taken, but more importantly, the progress that is being made with mitigating actions that are being put in place can be tracked. I want to thank you for your attention, and I really look forward to the discussion and the questions. Thank you.
Thank you, Mr. Gauthier, for a very interesting presentation. Up next, we have Dr. Peter Zantrizos, President and CEO of Terragon Corporation. Terragon Corporation brings us a technology today that essentially eliminates the need for waste management as we know it and liberates much needed energy for our own use. Dr. Peter Zantrizos, you have the floor.
Good day, everyone, and thank you for listening to my presentation. Today, I would like to discuss with you an alternative to our current waste management practices. Currently, most of the world is separating the people producing the waste from the people processing the waste. In doing so, we actually enable a very irresponsible behavior from the producer of waste, and we're also creating a business whose, just like any other business, whose main purpose is to grow and to be profitable. The consequence is obvious. For example, in Canada, for the past 20 years, the waste management business has grown 3 times faster than the economy, and yet the people today in Canada generate more waste per person per day than just about anyone else in the world. The alternative to this separation of waste processor from waste producer is to actually enable the waste producer to use all the byproducts that are now rejected as waste. This applies to both solid and liquid waste streams. We call this the total resource utilization habitat, a place where all byproducts are used to produce things like carbon, biochar, carbon to be put into the soil, energy, water, and ultimately combine all these ingredients for producing food through regenerative agriculture. In order to enable this true habitat, we had to develop two completely new appliances that were be used locally to convert waste to resources. One of them is called MAGS, Micro Auto Gasification System. And this is basically a boiler that uses waste as its main fuel. The other is WET, wastewater electrochemical treatment technology, which basically allows us to clean and reuse our wastewater. These innovative products were developed with support from Sustainable Development Technology Canada and the US Office of Naval Research. They've won multiple awards in Canada, the US, the UK, and Germany, and they're commercially validated through many installations globally, including some installations in cruise ships. MAGS is an energy appliance that works very much like any other energy appliance. The difference is that it can start with any fuel. So there's a gasifier that converts any solid material or liquid, such as oils, for example, into a syngas. By producing syngas, we now have the fuel for our boiler. The syngas is combusted in a chamber, and the exhaust of the combustion chamber passes under the gasifier to provide the energy for the gasifier, and then is quenched and cleaned to ensure clean emissions and to recover energy. It can process any material, paper, plastic, cardboards, textiles, any kind of leather, any material can be processed with this device, and it sequesters carbon to produce biochar. It also offers very good energy efficiency, producing about 120 kilowatts of thermal energy, which is about 75% of the total energy contained in the fuel. MAGS is a simple device that is used commercially in many applications. Some of the applications are shown here. They include ships of various types, from cruise ships to working ships to transporting ships. It's used in many communities. We have installations in the Philippines, in Hawaii, in Australia, in Singapore, and for the military, where we have primarily installations with the US and the Canadian military, both on the Navy side and also on the other operational side, the bases and the maintenance facilities. And it's used by industry in many applications, including, for example, treatment of biomedical waste, shipyards, explosives producing factories like Dyno Nobel, and producer of cannabis. It is worth noting that there was no classification, there was no equipment description for MAGS. So UL, in collaboration with Standards Council Canada, has created a new definition as a water heating gasification appliance. And IMO is working towards creating also a new classification for equipment that works, it's cleaner than marine incinerators. That's the main advantage of MAGS. MAGS is extremely clean. The emissions of MAGS, as compared not to incinerators, but compared to boilers, you can see the table here. And you can see that MAGS is actually cleaner in terms of both particulates and significantly cleaner in terms of dioxin production as compared to a standard diesel boiler. Now, turning our attention to water, I want to make a point that water is used very poorly in our current system. We have basically what I call one pipe in, one pipe out. We use one type of water for all our applications. We drink with this, flush our toilets, we water our plants, but there's no requirement for this type of water to be used. We also have, in all these applications, we also have one type of exit, one pipe out, which basically means that all our water exiting our homes goes through the same pipe that our toilet water goes and gets contaminated by our toilet water and cannot really be effectively reused. If we change that and we start thinking in terms of water for purpose, we realize that we basically have two types of water, types of wastewater that we use, one of them being gray water, which comes primarily from relatively clean emissions, like showers, laundry, and things like that. And we have black water, which comes primarily from our toilets and perhaps from our kitchen sink. Water we use, it could also be three types of water. It could be water that we use for potable water, we have water that we use for cleaning, and we have water that we use for our plants, for irrigation. If we take that approach, then we can do some very simple things to reduce our water consumption, and it's eliminate wastewater discharge. For example, if we take the water, that effluent water from our showers and our laundry and clean it and reuse it for our laundry and flushing our toilets, we reduce water consumption at home by about 60%. The same thing can be said about black water, which can be cleaned and used for irrigation, and the plants will love the extra nutrients. Our wet technology works based on electrochemistry. Basic elements of the technology include electrocoagulation and electrolytic oxidation. Electrocoagulation is a process in which basically a coagulant is released into the wastewater stream along with microbubbles. The coagulant essentially coagulates all the suspended particles in the waste stream, and the bubbles, the gas bubbles, are lifted to the surface where it can be removed. Whatever is dissolved in the waters cannot be removed by electrocoagulations. We can use electrolytic oxidation to essentially burn any organic molecules in situ and purify the water. It is excellent for deactivating and activating any pathogens, including COVID-19 and other viruses. It does not include biological treatment, and it does not include the addition of any chemicals. We have three types of systems, three types of appliances that we can offer. One of them is for the treatment of gray water, and we call this water G. And this idea of this system is to produce high quality water for utility purposes. We have the wet O, which can clean oily water, like the water that comes from a bilge of a ship, and potentially reuse it for cleaning purposes. And we have the wet S, which is essentially the treatment of black water or sewage, and the water effluent can be either safely discharged or used for irrigation. The main advantage of the wet system is that it is extremely robust. Biological systems work exceptionally well, but however, they are not, they require constant conditions. For example, the nutrients that you supply to the system must stay more or less constant and feed the bacteria, as well as if you use any chemicals that will kill the bacteria, then you will not have an effective wastewater treatment process. So for places like, for example, ships, which are not used all the time, where they stop and they get passengers to come on and off, the bacteria simply dies from a lack of nutrients, and the systems do not work. Anytime you scale down a wastewater treatment technology, it is very difficult to maintain constant operations. In a home, for example, someone goes on a weekend away, and all bacteria in his wastewater system would die. Electrochemistry is very different. It's on-off, and you supply the treatment on demand, and it is extremely robust. So you'll get the same quality treatment no matter how long the system has been offline. I want to explain an application for all these things that we are actually working on, and see how all these technologies can fit well together. So here we are working in a community called Hay River. It's a community in the Northwest Territories of Canada, very far north, just below the permafrost. And there's a native community that lives there, about 450 people, that have a waste management problem. What we do now is we take the organic waste and produce compost from it. We take the cardboard and other wood-based materials, waste streams, and we produce biochar. We can combine now the biochar and the compost and produce highly fertile soil. We can also use the rest of the waste to produce heat, to maintain, and through pipes we deliver this heat to the barns so that we can actually maintain the animals more comfortable during the winter months. And we also take water from the groundwater, which is contaminated with natural organic matter and with arsenic, and we purify that water and we can use it for the farm. We can use high quality potable water for the farm. So the farm now has good soil, good water, and nicely heated barns. And using these, they can actually grow the food that the community needs. So the community went from a waste problem to actually food security and jobs. This basic concept can be applied, we call this the ARC, the Autonomous Resilient Community. And this can be applied to anywhere. It does not have, it is essentially a way of using waste streams into regenerative agriculture. And it can be applied in the north, it can be applied in the tropics, it can be applied in isolated remote communities, or it can be applied in main urban centers throughout the world. And an example of that is application in Kalaupapa National Historic Park in Hawaii. And of course, I mentioned Hay River before. And you compare that with other applications, for example, in places like Singapore, where we actually using the horticultural waste produced at Gardens by the Bay to produce biochar and energy. The energy is to use to provide the hot water that the Gardens by the Bay needs, and the biochar is used to enrich the soil for the gardens. The ecotourism is probably one of the best applications of this concept. It is understood by a lot of people that the first to return to tourism will be ecotourism, will be people that are basically looking for an experience in nature and who also care about the fact that the habitat, the hotel, will maintain nature clean and as healthy as it is now for generations to come. Just imagine a true hotel, a total resource utilization hotel, where basically all the waste streams produced by the hotel are utilized within the hotel to produce energy, to produce water, and to produce some healthy local food through regenerative agriculture. Keys are zero waste streams and an image for the hotel that will attract guests. Now, guests in our model, guests are paying for all this through a green fee that the hotel charges in addition to the nightly rate. We're making this offer to various hotels in the Caribbean, in the Mediterranean, Southeast Asia, and of course, Central America and Canada and the US. Our mission is to change the way people view waste and to realize that these are resources, and if we know how to use them locally, we should stop exporting them to others. This is a significant impact. Waste, we're just as much as destructive because of the way things we consume as we are because of the things we reject as waste. And if we can get rid of the throwaway society, I think that we're going to be a huge step closer to sustainability. We believe that a resilient, a healthy world does not include the concept of waste. We're a company that is recognized as a leader in this, in enabling this resilient infrastructure that we believe in. And our technologies are being diversified to be larger scale systems, smaller scale systems, and really enable the zero waste habitats, the zero waste communities. Thank you very much for listening.
That whatever we produce is done so in a sustainable way, including the wastes that we produce as well. Perhaps I could begin the question and answer session, which we'll go to next, by directing a question to Kaya of Carbon Cure. Okay, I'm getting an echo, so let me try and shut this window down.
Dr. Gary, can you hear me?
Yes, I can. What I'm doing is shutting down my conference window because that's producing a bit of an echo. All right. Yes, so first question would be, let's see. Okay, so in your presentation, you mentioned that designers are shifting their focus from operational carbon to reducing embodied carbon. Perhaps you might want to expand a little bit more on this point. How would you differentiate operational carbon? Yes, please go ahead.
Yeah, thank you so much for the opportunity and for everyone that has taken the time to listen in. Our mission is to decarbonize the concrete industry, and as we know, the carbon footprint of all concrete structures tends to be directly related to the cement content, and we're kind of in an interesting sweet spot now where most structures are very efficient in terms of heating and air conditioning, and which is known as operational carbon. And the shift of developers, owners, architects, engineers is now shifting to what is the carbon footprint of the structure during construction. So the timing is very fortunate for us in that as we're coming to market internationally and preparing to launch in Malaysia very, very soon, we can now engage designers in Malaysia in this discussion and help them lower the carbon footprint of their concrete structure.
Thank you so much for the response. Perhaps a question now for Jean-Francois. Let's see. There's a question about the sensitivity of the detectors, I suppose, that you have on these satellites. At what concentration can you detect emissions of methane?
Thank you, Dr. Peter. So I mentioned that sorry, Dr. Gary, why am I talking? I'm messing up the two doctors here. Thank you, Dr. Gary. So in my presentation, I referred to the new satellite being an order of magnitude better, 10 times better than the previous one. But to put into perspective, our first satellite, Claire, was looking at leaks in the order of, and we don't talk about concentration as much as flux rate or emission rate. So the first one, Claire, was looking at emissions in the order of around 10,000 tons per year. So what we're looking at with IRIS now is emissions in the order of 1,000 tons per year, and potentially as low as several hundreds of tons per year, depending on the wind conditions. So even with the previous satellite, we were finding leaks all over the world, dozens and dozens of leaks. Now, with a detection threshold much lower, we expect, and we're already seeing a month into the launch, after the launch of the satellite, that we're finding much smaller leaks. That's the order of magnitude we're looking at, about 1,000 tons per year.
Okay. Yeah, thanks so much for that clarification. A question now for Dr. Zantrizos. I guess that some people have visited the sites, the conference sites and the exhibition sites, and there's some question about the scalability of MAX and WET. Would you care to expand a little bit on how your technologies can be scaled up, notably for handling the volumes of waste and I guess liquid waste in urban centers?
Yes, I'd like to start by saying that we're not a waste treatment company, we're an appliance company. So when people start thinking in terms of waste management, they're still thinking the conventional way. Garbage trucks coming around, collecting waste, taking it away, and bringing it to a central processing facility. We're not a solution for that approach. We're a boiler. So if people are interested in having a boiler in their hotel to produce their hot water, they can have a boiler that they can use their byproducts as a fuel and not have to produce waste. The moment that someone rejects their byproducts as waste, our approach no longer is functional. So our technologies are scalable, and we are making, if you look at the MAGS, for example, MAGS about 120 kilowatts. So it's kind of a similar boiler size as any hotel. I am working on, our team is working on two systems. One is a larger scale technology which will be about 5 times bigger than MAGS. And the other one is a smaller scale technology. Ultimately, the idea would be to have our home furnaces being able to use our byproducts as our fuel. So this is where the scalability concept comes in. We're looking at the scale from the home to the hotel to the community. We're not looking at the scale of a big city, but a big city can also have a distributed system where every small community takes care of its own byproducts and uses its own byproducts beneficially and has no need for garbage trucks or sewers.
Okay, thank you. So I suppose it's a different way of thinking about how we consume, and to think of consumers actually not as a dead end, but as a producer of some other resource that we need to put to good use. And hence my raising the issue of the circular economy here. Perhaps a general question to all three of our speakers. What would you say are the top 3 challenges facing Southeast Asia today that Canadian companies can provide solutions to? This is a question from Thomas Ebolz. If you would very briefly, what would you say are the top 3 challenges facing Southeast Asia that Canadian companies can provide solutions to? Maybe we start with Kaya Solowski.
Well, if we approach it from the standpoint of climate change, I think that with so many coastal communities, seeing the risks of the melting ice in the north and the south encroaching on their coastlines, I would say that that's likely a dominant one. I'll turn it over to my colleagues for the other 2.
Right, Jean-Francois?
That's certainly a very relevant one. I would add to that the just the overall energy transition. I mean, it's Southeast Asia is a very populated area of the world, and moving away from coal and from other sources of for example, other hydrocarbons, and moving towards LNG and eventually, using that as a bridge towards more renewables is a challenge that's relevant in that region, but also around the world. So it's certainly a common theme.
Thank you. And what about you, Dr. Peter?
Yeah, I would say that the main problem of Southeast Asia is the same as the rest of the world. It is we have broken down our communities, and we've become dependent in a global market that provides for us our energy, our food. And I think that until we actually return to the idea of being locally dependent on energy, water, our primary resource, energy, water, food, and commit to regenerating our local environments, I think that we're not going to be able to solve these problems. I'll give you a very specific example how different things can be. If, for example, here in Canada, I don't know the circumstances in Malaysia, of course, but I do understand Canada quite well. And here in Canada, we subsidize diesel for our northern communities very heavily. What this does is makes these communities dependent on far away resources for their survival, and makes other kind of local energy potential sources less economically viable. So if we can just enable people to generate their own resources, we're creating capability, we're creating resilience, and we're eating great quality local food. So that's my main point.
Okay, yeah, thank you very much. All very insightful responses regarding what the challenges are in Southeast Asia today. Before I go any further, I'd like to send a message out there that after this conference or this session, please feel free out there to visit the Canada Pavilion, the Canadian Pavilion at iGEM 2020. And what you will find there is, apart from the Canadian High Commission site, 16 businesses, including the three businesses that have made presentations here. So do feel free to drop by, and of course pick up your diamonds when you get there, and perhaps win some prizes. Let's go to another round of questions, if you would. Let's see. We have a question here about convincing ready-mix contractors. I mean, it's already the cement and concrete production is already proceeding, particularly in developing countries, very, very rapidly. You can't drive a kilometer almost without passing a batching plant or some other kind of facility like that. You move anywhere near the city and you see buildings under construction. So you do know that there's concrete moving around and lots of it being produced. What is it in it for any either a purchaser, someone who's developing, building high-rise structures? What is it in their interest, or what is it perhaps in the concrete supplier's interest to add another piece of machinery to their system, and perhaps add more cost to their system? How would you propose this as a business case, and what kind of offsets would you say that the installation of your technology would bring to the concrete, to the building industry? Mr. Solowski, please.
Yeah, Dr. Gary, thank you for the question. Very interesting question. The growth of economic development in Malaysia is rapid, and even though we've had a temporary slowdown in activity due to COVID-19, the expected pace of growth and continued building of both infrastructure, residential, commercial, retail is expected to continue on a very rapid pace. And you're absolutely correct. It's while it is a growing industry, it is incredibly competitive, and the motivators to consider the adoption of a green, clean tech, low carbon technology like ours is really twofold. One being the designers that I spoke about earlier, where they are very interested in doing the right thing and lowering the embodied carbon of their of the built environment. But on the other side, you have the value engineering, the incredibly competitive market in Malaysia that is just as focused on the bottom line. And it creates an environment where value-added products and investment in innovation needs to have a clear return on investment, and very rapid. So our technology is unique in that it's a retrofit. It can be installed within one day in an existing factory. And the savings from reduction of cement offset in large part the adoption of the technology. So the concrete going to market can actually be, in most cases, neutral in comparison to control concrete. So it can be profitable for a concrete producer, a differentiator, and it can really help at the end of the day the embodied carbon footprint of the concrete built environment. So very nice question. Thank you.
And may I append a question to that? Is CarbonCure or has CarbonCure explored any of the avenues related to getting carbon credits, for example, for the carbon that you've managed to sequester in the concrete? Is that something you've explored before?
Very early days. We have successfully transacted 2 tranches of what we call emissions credits in North America. and we fully intend of sharing the proceeds with our end customer, the concrete producer, as we develop this business. So still very early days. Every country has its own, I would say, developing scheme around carbon taxation and credits and the management or the trading of emissions. But we view it as a mechanism to fuel our growth, and we definitely plan on sharing the proceeds with our customers.
Thank you very much for the insights. On to another question for Jean-Francois. Analytics and big data are emerging tools when it comes to some of these technologies, particularly remote sensing. In your particular case, I'm sure it requires a lot of processing to take the raw image data and then produce it into something that people can understand, maybe a sort of time lapse or time series of concentrations and movements. How would you describe the algorithms you use to process the data that you receive from your satellites?
Thank you, Dr. Gary. And this is an interesting question because very early on we realized that obviously we generate very vast quantities of data, and providing this data to customers is in many cases interesting, but very quickly they become overwhelmed. And a common theme that's increasingly coming up now is the idea that customers are looking for insight and not data. So they want the raw data. It's nice to have it, but they want to know what to do with it. So that's great that you see emissions, but should I take action? Is it normal? Is it near a school or a residential area? Should I prioritize action here instead of there? So once we recognized that, and that was shortly after the launch of the first satellite, we started accelerating this. So the last 2.5 years, we started investing a lot on the analytics side, and that's currently the fastest growing part of our company right now, actually. So what we do is that we ingest data from other sources, so other satellites, databases, accident databases, production databases, visual imagery from satellites, information on flaring, for example. We incorporate all of that with our data, and then we devise machine learning and artificial intelligence algorithms that look for trends and patterns. And they help us, first, they can help us better direct our satellite observations, for example, by looking at hotspots and looking at regions where leaks are more likely. But we're also devising predictive analytics where, by looking at these patterns, we can start determining where leaks will be most likely to occur. So most analytics is backwards looking. This predictive analytics scheme is more forward looking. So we're looking at different ways of addressing this. These particular examples were for oil and gas, but we're also devising applications that are relevant for waste management, for the coal industry, for agriculture. So all of this to say, data is nice, but insight is what the world really wants and needs, and we heard the message, so that's what we're focusing on.
Yeah, and a bit of a follow-up question in this regard. I understand that your service is a contract-based service, and that folks can request that certain areas be monitored over specific periods of time, etc. But in terms of your own collection of data, has it been possible to detect leaks that were not otherwise noticeable from the ground, and actually inform someone before an explosion occurs if they have any kind of methane leak? I mean, these things happen fairly rarely, but they do happen from time to time, where we have a family that goes on vacation and they might have a small leak, but because the house is closed up, it sort of builds up in the house, that sort of thing. Has that opportunity ever presented itself to GHG? Yeah.
No, that's an interesting question, Dr. Gary, once again. So the types of leaks, we have to remember we're 500 kilometers up in space, right? So we're quite far from the surface. So the leaks still have to be quite large for us to notice. So residential leaks might be outside of what we can realistically look at. So I'd be stretching the truth here if I told you we can look at leaks from a gas stove in a house, but we have, however, identified many leaks over the last 4 years at industrial facilities that, believe it or not, the operators did not know about. So some of them actually in Central Asia over a period of the last 2 years approximately. That we've identified. Actually, these leaks were first identified from space, so nobody knew that they were there. We eventually reached the operators, let them know that their facilities were leaking, which eventually led them to go on site and close up the leaks. So it's something that is not rare, and actually the response we get is not always favorable either, because the first reaction is, "Oh, you're spying on me. I follow all regulations, everything is okay around here." When they realize that our mission is not to finger point, but to work with them, the reaction changes a little bit.
Yeah, and I think that's precisely the response that I think the listeners were hoping to hear.
Right.
Okay. Yeah, so much for thanks, for gratitude.
Right.
But yeah. Moving on, perhaps, to Dr. Zantrizos, what we find in Malaysia oftentimes is that what we think of in Malaysia as waste, and I do want to make a note here that you did mention that you are an appliance company, not a waste company. But the situation in many developing countries, as consumers become more sophisticated, is that they already begin separating their waste into the various streams. And so different places suffer from different challenges in terms of waste. We in Southeast Asia produce a lot of organic waste and a lot of plastic waste. And it used to be completely intermingled. There was no way to separate it. But what's happening now is increasingly consumers are segregating and actually cleaning their used plastics and metals, and in many cases are even separating out their compost, their organic wastes for composting, as long as it's not meat and bones and that type of thing. But eggshells and other products usually end up nowadays moving towards more of a compost type of end use, and ends up in gardens. What would you say to I guess the situation where your technology, how would you optimize the application of your technology in a situation where there's a cultural shift beginning as consumers begin to understand that waste isn't waste, it's just alternative resources?
Well, I think that what is going on in Malaysia is positive, and I think it's great, and it needs to be encouraged further. If we think in a very simple way, we really do produce only 3 types of byproducts. We produce byproducts that we can use to make compost, we produce byproducts that we can use for energy, and we produce byproducts to make materials, which is through recycling. At the same time, we produce 2 byproducts in water, which is gray water and black water. So if we think of these 5 byproducts that are basically our entire waste streams and separate them and use them beneficially, so every time we have a byproduct, whether it's a banana peel or it is a packaging material, we have to think in terms of, okay, of these 5 options that I have ahead of me, which is the best way to use this material. And this changes from place to place, because some places they can recycle and reuse plastics, certain types of plastics, certain other places they can't. So, for example, if you go into the Arctic, where bringing plastics back from the Arctic is tremendously expensive and not viable, and where they need the energy, then the idea of using these plastics, which have come from oil, to actually use them similarly to oil as a fuel, it makes a lot of sense. So I think that the general trend is very positive. The thing that I am very concerned about is that there is hidden within it a business case which is not really relevant to the sustainability objectives. So a lot of the things we do are really only encouraging the growth of business, not really. We do this in the name of sustainability. For example, I remember visiting a site, a very brand new landfill in a city in Canada, and they were doing everything right, doing the composting and recycling and doing all the things that they were supposed to be doing. And then they had all these bales of plastic, that thin film plastic, and I asked them, what do you do with all this stuff? And they said, well, we ship all this stuff to Asia for recycling purposes. And I'm sitting there scratching my head. I said, how is it possible that the value of this material is not enough? There's not enough value there to be shipped all the way to China or any other country in Asia. It doesn't make any sense. It makes business sense, but it makes no environmental sense. So that's why locally repurposing all our byproducts for local use is so critical.
Thank you so much for that response. And we're coming up on the 11 o'clock hour, but I think to be fair, I should give the three speakers a chance also to, as they're thinking of moving into Malaysia and beginning to deal with the Malaysian legal system and regulatory framework, perhaps a general question to all three of you. Have you encountered any difficulty with the legal system here, the registration of corporations, or any other type of regulatory barriers that you might find? And perhaps what advice or what proposals would you make to either any level of government, like local authorities, municipal authorities, state or federal government, in terms of facilitating the uptake and the transfer of these sorts of technologies? Let me see, do we still have Kaya here? Perhaps we might have lost Kaya. Yeah, we might have lost him. So can we go to Jean-Francois?
Yes. So we personally at JSHISA, we haven't. We're looking at expanding into the market. We're actually looking at opening a presence in Southeast Asia in the next probably 18 months to 2 years, realistically. So Malaysia is obviously one of these options. And so the Trade Commissioner Service and the embassy, the Canadian Embassy, have been very useful resources for us, and organizing an event like this actually to put us in front of the community, of the stakeholders in Malaysia has been very helpful for us. So we don't have any direct experience yet with establishing a presence. We've had discussions with companies that will hopefully soon be customers, and that's been going over very smoothly so far. So that's been the extent of our experience at JSHISA.
Well, if I might interject with a question that comes from Mr. Simpson Tan, University of Malaya, then he says, since you're using a spectroscope, would you be able to observe other gases as well, such as carbon monoxide or even particulate matter such as the haze? Perhaps you want to field that question now?
Yeah, very quickly, I can confirm that this type of spectrometer is entirely adaptable to other gases. However, it has to be tuned on the ground before we launch it. So once it's launched, It's very precisely tuned to one gas. There's a possibility to look at many gases, but that's not optimal. The first satellite was actually designed to look at CO2 and methane. We, as a lesson learned, we decided to focus on methane only now, but now we're starting to turn our attention back to CO2. But if a business case forms for other gases, we're absolutely inclined to look at it and interested in expanding to other pollutants as well. So the technology is entirely adaptable.
Thank you, Jean-Francois. Dr. Zantrizos, on the regulatory framework and Malaysian laws?
Yes, I do not know about Malaysian law, so I will answer about something quite close to you, which is Singapore. And I think Singapore is doing this very, very well. And I'll explain what I mean by that. We brought a new appliance that nobody knew what it was like, right? So, and what was there for. In Singapore, the regulations were that you're not allowed to operate incinerators inside the city. So people that first looked at it, they said, well, this is kind of an incinerator. We say, well, no, it's not an incinerator, it's a boiler. And what they did is establish something they call a sandbox project, which allows us to operate for 2 years in a very, very prestigious environment, Gardens by the Bay, and they can take these 2 years to assess the technology and develop the proper regulatory framework to see if this technology could really be used in hotels or other places. So that's one side of it, which is the regulatory recognition of what this technology is and how it can be used within both urban and sort of natural kind of more country environments. The other side of it is the business implementation. And this is really the key challenge for us. Effectively, right now, we're working with a company in the Philippines to try to develop the business model. It is very difficult for Canadian companies, a small Canadian company like ours, to actually serve the needs of Malaysia, for example, or the Philippines, or Thailand, or any other of these countries in Southeast Asia. It is much better if we can find a commercialization partner that would actually manufacture the products there, service the products there, and we can provide the technology. Canada is doing an exceptionally good job of developing highly innovative technologies that could help the world. But the world has to pick up these technologies and use them. This is, I think, the two basically elements. One of them, there has to be the proper regulatory framework, which means recognizing what these technologies are and developing regulations for these technologies. And the other one is developing the partnerships that are needed to commercialize effectively.
Thank you very much. And I note that we are at the end of our time. But before we go, I would like to offer Jean-Francois and Dr. Peter Zantrizos a chance for some parting words to those who are viewing this online presentation, provided, of course, by the Canadian High Commission. What would you like to leave our audience with, Jean-Francois?
I would simply like to leave them with a word of thanks. So to the High Commission, to the conference, this has been a very insightful discussion. So thank you for the invitation. And I'd just like to point out that Kaya has joined us as well. So he's back in the room as well.
Okay. Okay. Why don't we go to I don't know, perhaps you've been listening, Kaya. Why don't we try to incorporate your final words? Before you get to your final words, some thoughts about the current legal system in Malaysia and the regulatory framework. Have you encountered any difficulties, and what advice you'd like to give any level of government here in terms of the ease of starting business here in Malaysia? And then perhaps some parting words for the audience.
I appreciate that, and I apologize for technical difficulties. I'm dialing in from Vancouver, and seemingly the internet connection disappeared for a minute there. But thank you for the question. We are in the very beginning stages of working with the regulatory environment. In Malaysia, we have recently obtained regulatory approval in Singapore. And as we know, both countries have quite a bit of synergy as relates to the construction and the concrete industry. So we feel that having made some inroads and secured regulatory approval in Singapore will allow us to commercialize our technology in Malaysia very quickly. So we look forward to working with the government bodies as far as local testing is concerned. And with respect to closing remarks, it really was our sincere honor to participate in this discussion. And I appreciate both the moderation and being in such esteemed company as Jean-Francois and Dr. Peter. So thanks again for the opportunity.
Most welcome, Dr. Peter.
Well, again, I'd like to thank everyone who's participated in this and everyone who's helped put this together. I also like to thank Gary for organizing this. And as a final message is act locally, because that's the only way we're going to get out of this mess.
Thank you so much. And thank you to all three presenters. So once again, wrapping up here, we heard first of all from Mr. Kaya Solovsky, the Vice President of Business and Development at CarbonCure. Their business is removing greenhouse gases, notably CO2 from the atmosphere, and locking it up in concrete products. We also heard from Jean-Francois Gauthier, Director of Business Development at GHGSat. Now, their business is actually sensing remotely methane from satellites, and I understand also from drones and other types of remotely operated vehicles as a service to companies. And third, we heard from Dr. Peter Zantrizos, President and CEO of Terragon Corporation, who are, importantly, not a waste management company, but an appliance company. And once again, part of the circular economy technology scene in Canada, hoping to find a foothold and a very welcome home in Malaysia. I'd like to thank all three presenters, and thank also the Canadian High Commission for having this session of part of iGEM 2020. And as parting words from myself as the moderator, once again, do visit the Canada Pavilion at iGEM 2020. You will find, apart from these three extremely outstanding technologies and businesses, 13 other businesses that you can look into in terms of Canada's contribution to sustainability, toward mitigating climate change, and towards sustainable development. Thank you all very, very much. It's been a pleasure and an honor, and I wish you all a pleasant morning, afternoon, or evening, depending on where you are. Thank you, and have a good day.
Thank you.
Thank you.
Thank you.